Paper of the day is task scheduling for highly concurrent analytical and transactional main memory data workloads. It's a 2013 paper. This paper shows how to exploit the performance benefits of task scheduling for main memory DBMS. Firstly, they use application knowledge about blocking tasks to dynamically adapt the number of workers and aid the OS scheduler to saturate CPU resources. In addition, paper shows that analytical queries should issue a low number of tasks in cases of high concurrency to avoid excessive synchronization, communication, and scheduling costs. To achieve that, they maintain a concurrent hint, reflecting recent CPU availability that partitionable analytical operations can use as a limit while adjusting their task granularity. Authors integrate their scheduler into a commercial main memory column store and show that it improves the performance of mixed workloads by up to 12.5% for analytical queries and 370% for transactional queries. Looking at the benchmark and evaluation, paper uses TPC-H and TPC-C benchmark. They compare the following variations of SAP HANA. First, multiple pools, which is the original version of SAP HANA with the different thread pools. Second, single pool gnosis, which integrates the different thread pools of multiple pools into tasks for their new scheduler. This variation assumes workers blocked on synchronization primitive as working and include them in active concurrency level of the scheduler. Third, single pool, which is like single pool gnosis, but uses a flexible concurrency level by assuming workers blocked on synchronization primitives as inactive. Fourth, single hints, which is like single pool, but with the concurrency hint following the exponential moving average of free workers in the recent past. Partitionable analytical operations adjust their task granularity according to the concurrency hint. This variation is the best version of new scheduler for SAP HANA. The paper makes three key contributions. First, the paper shows that a fixed concurrency level for task scheduling is not suitable for a DBMS as tasks often block, essentially in highly contending OLTP workloads. Their scheduler adapts its concurrency level by detecting blocked tasks and give control to the OS of additional worker threads to saturate CPU resources. Authors show that using a hint reflecting recent CPU availability helps to adjust the task granularity of partitionable analytical operations. The concurrency hint improves overall performance significantly in case of highly concurrent environment and by reducing costs related to communication, synchronization, and bookkeeping. Third, authors show that they integrate their task scheduler into SAP HANA, a commercial main memory DBMS. Their task scheduler improves the performance of highly concurrent analytical workload TPC-H by up to 16% and of highly concurrent mixed workloads by up to 12.5% for analytical queries and 370% for transactional queries. Coming to PS score, overall it's nice read, so it gets 9 out of 10 on readability. With 10 pages long, it scores 9 out of 10 on length. Reproducibility and repeatability might be challenging, so it gets 8 out of 10. Industry value and learning meter is high, so it gets 9 out of 10 on each. Overall PS score is 9 out of 10.